For our nomenclature, we start here with one of our diacids. This diacid contains 3 carbons between the 2 acid groups. So that means it's going to be our 4th acid in the sequence of diacids, beginning with G, which is glutaric acid. In part B, if we choose to use the nitrogen as our root, then that means we're dealing with an aniline, and the carbon containing the nitrogen becomes carbon number 1. In addition, because we've done that, we don't need to put a number for aniline. We know by definition that the aniline carbon is carbon 1. Now, if we continue our numbering now clockwise, our first substituent doesn't come till the bromine at carbon 3. But if we go counterclockwise, our next substituent is the methyl at carbon 2. That's a lower number, and so that means we will number in that direction. We then just need to alphabetize these substituents, and so we end up with 5-bromo, 3-fluoro, 2-methyl-aniline. Finally, we have one more nomenclature question on this exam. The numbering ends up being the easiest piece on this one because we have an aldehyde. An aldehyde is one of those functional groups that is always defined as carbon number 1. And so we can then number from there along our longest chain to get our decane as the parent name. Now, before I try and write out the name, I'm going to make a list over here of what does this molecule have. And so at carbon 2, there's an alkene. 3 has an isopropyl. 4 has another alkene. We will combine them later. 4 also has a fluorine. 6 has an ether, which because of the higher priority group, the aldehyde, we name the ether here as a methoxy. Same thing is true for the alcohol at 7. Call that a hydroxy. We also need to account for the 3rd alkene in this molecule, starting at carbon 6. Carbon 8 has an alkyne. And then carbon 10 has both a bromine and a sulfur group. And we call that mercapto. In addition to this, we need to define all of our stereochemistry. So before we put the name together, let's do that part as well. So we'll start with our first alkene. And of our 2 substituents, we have the higher priority is the carbon over the hydrogen. On the other side, we have a carbon versus a carbon, but one of those carbons is bonded to a higher atomic number of fluorine. So that gets higher priority. We can see the higher priority substituents are on opposite sides, so that makes this alkene E. So let's erase those and go on to the next alkene, which is here. On one side we have a fluorine versus a carbon. Fluorine is higher atomic number than carbon. On the other side we have carbon versus hydrogen. Carbon, higher atomic number. The higher priority groups are on the same side. That makes this Z. Now we can do the alkene over at carbon 6. On one side we have oxygen versus carbon. Oxygen is higher atomic number. We have the same set on the other side, oxygen versus carbon. Our 1s are on opposite sides. That makes this one E as well. And then finally, at carbon 10, we have a stereocenter. So bromine, highest atomic number, followed by sulfur and carbon. Our lowest priority, the hydrogen, is already pointed back, so we don't have to change anything. Our arrow goes counterclockwise. That makes it S. So now we just need to put all of this together. So what comes first alphabetically? Well, before we do that, we need our stereochemistry. Two E, 4Z, 6E, 10S. Then our first substituent alphabetically is the bromine, 10 bromo. Next comes our fluorine, 4 fluoro. Then we go to 7 hydroxy. From there we go to isopropyl. Recall that iso is not numerical, and so this gets alphabetized under I. And finally, then we go to mercapto, because MER comes before the MET of the methoxy, which is next, 6-methoxy. We've now accounted for all of our substituents, so now we need to give our parent name, which is decane. Then we have the 3 alkenes at 2, 4, and 6. 2, 4, 6, triene. 8, ine for the alkyne, and finally Al for the aldehyde. Remember, the aldehyde, because it's defined as carbon 1, does not need a number.